Okay, this video is about a demonstration called Name That Precipitate, and it accompanies a homework assignment in the general chemistry class that's also called Name That Precipitate. And the purpose of the demonstration is to show what happens when you mix ionic solutions, soluble ionic compounds, and then the students watch what happens, and on the homework sheet there's 6 reactions, and each pair of test tubes will represent 2 of the solutions that are used for the 6 reactions that are all different. Helping me out today is the person that did all the work in setting this up, Jennifer, our stockroom supervisor and instructor at the university. So I asked her to perform the demo. That way, if it doesn't work, we can all look at her and laugh at her and taunt her. But I already did this morning, so I know it will work. I want to give credit to where this demonstration came from, and so the easiest way to do that is to hold up the book. It's called Chemical Demonstrations, a Source Book for Teachers, Volume 2, 2nd edition. And the authors are Summerlin, Borgford, and who's the last one there? Ellie, Eli? Okay. E-A-L-Y, okay. So anyway, what the students are supposed to do is, in this assignment, is to first part is complete and balance each equation. And so let's go to the first combination of test tubes. This is HgCl2 in test tube 1 and Na2CO3 in test tube 2. So if you'll combine those. And the students complete the equation, so they write down the products. These are double displacement reactions, so they should know what's involved with completing the equation. And then in part A, that is part A, complete and balance each of the equations. Part B is to name each reactant and product, and if a compound appears more than once, they only have to write the name the first time it occurs. Part C is to write the ionic equations, and part D is to write the net ionic equations. And they have a handout that I'm holding right now. And so Jennifer just combined HgCl2 and Na2CO3, and then the students, when they complete the equation, they write AQ after the appropriate formula of the compound, and they write S after the compound that forms a precipitate. Now, how do they know what compound that is? They use the solubility rules from the textbook. Okay, so that was kind of a brown precipitate, right?
Yes.
Okay, very good. All right, next she's going to mix PbNO3 and Ki solutions. And this gives a very vibrant yellow solid as a result. Notice that in both of these reactions so far, the test tubes, before they were mixed, contained solutions that look just like water. After mixing the solutions, now again you see a precipitate. So once again, they complete the equation. They use the solubility rules to figure out which of the possible 2 products is responsible for that precipitate. Okay, reaction 3 involves HgCl2 again. And you can see it looks just like water until Jennifer mixes the second tube, and that contains Ki. Now, something the inorganic students in the audience will find out about later is why we have a different color when one of the reactants here was the same as the first pair of reactants, and that's mercury 2 chloride. But that's another subject. So here we get quite a nice orange precipitate. Okay. So far so good. We're halfway through. Here we have barium chloride on the, whoop, I gave away the name. BaCl2 on the left and Na2SO4 on the right. And go ahead and mix them. This is not nearly as pretty, but it's still a solid produced. Just as an FYI, this solid is used as a weighting agent in drilling fluids used to drill oil and gas wells. Okay, so that was white. The next pair of compounds is CuCl2 and Na2CO3. Na2CO3 was also in the first batch of test tubes, so it reappears. Notice that this is the first and only test tube that has a blue color. So you will know, if you don't already know, why that is, why that test tube is blue. And once again, it's CuCl2 plus Na2CO3. Go ahead. Now, because the color was blue before mixing, it's a little bit hard to tell if the precipitate that you see is blue or if it's just because of the blue solution. The answer to that question hopefully will be after we let the precipitate settle for a while. Okay, that's our fifth of six, and the last pair of test tubes is going to be mixed now. It contains Na2CO3 plus Ki. And this is sort of like the case where you see no solid. So when the students predict the products of this reaction, they should have AQ after the formula of both products, because as you can see, there's no precipitate. Okay, and then I've asked Jennifer to come back in about 45 minutes or so and just hold up each of the test tubes, because right now they kind of look like suspensions. So let's see how different they look after they've had time to sit around. Okay, I'm going to stop it now, and then I'll start it again in about 45 minutes. Thank you, Jennifer.